Okay, we have the current I in the circuit with voltage E, resistance R, capacity reactant X sub C, and inductive reactance X sub L is this equation. We're going to find I, and then we're given all the rest of the equations. So I'm going to start by filling those in. Well, if it's going to let me draw. So E is 12, and I'm just going to write this as CIS 25. And then R is 3 plus 4 minus 6I. So then a little bit of cleanup here. And I have 12 CIS 25, 3 minus 2I. Now at this point, your top is in trig and your bottom is in rectangular. You have the option, you want your answer in rectangular, but you have the option, you need to match them up so you can combine them. It is going to be easiest to actually switch them to trig form because then you can use your quotient theorem rather than do the top out and then have to FOIL to rationalize denominators, control the bottoms. It's going to be a couple of pages of algebra if you go that way. So instead what we're going to do is we're going to rewrite the bottom. So if I draw this, this is 1, 2, 3, 1, 2, this point right here. Here's my triangle. Okay, so this is over 3, negative 2. So then this here is 9 plus 4, square root of 13. Okay, that's going to be my R. Now I need to know what theta is. So tangent of theta equals negative 2/3, opposite over adjacent. So I'm going to get out my calculator. First thing I'm going to do is I'm going to put this in degrees because that was in degrees. So I'm going to make sure I'm in degrees. And I'm going to do inverse tangent of negative 2/3. Okay, negative 33.6, but I want the actual first, so I'm going to add 360. I need to be in the fourth quadrant, but I don't want the negative version. So I'm going to use theta equals 326 I'm going to do 3099. Couple of things here. First of all, it asks you to round to a tenth. So always keep at least 2. You can store data if you need to on some of these problems, or you can just simply write down a couple of them. I try to use as much as I can from the problems, but sometimes it doesn't work out. So then I'm going to rewrite this. I have 12 CIS 25 now over the square root of 13 CIS 326.3099. Okay, now I'm going to use my quotient theorem, which tells me out front is going to be 12 square root of 13 and then CIS, and I'm going to do 25 minus this. So I'm going to do 25 minus my answer, and I'm going to get negative, and this I'm just going to leave negative 301.3099. Okay, so what does this mean for me? Well, when I write this out, now I need to convert this to rectangular, so this is cosine of negative 301.399 plus 12 square root of 13 sine, and there's an I in here, negative 301.3099. Okay, so I'm going to put this in my calculator. So I'm going to take the cosine of this, times it by 12 over the square root of 13, and I get 1.7. So my first thing is 1.7 plus, okay, now I'm going to do the second one. So I'm going to do the sine of negative 301.3099 times 12 divided by the square root of 13 and 2.8 because I tenth, and so there is our answer in rectangular coordinates. This up here would have been the trig answer if they asked us for it. So you can see here as we do this, we have several options. There was a 2 pages of algebra option, but we chose to use our trig form and our shortcut formula, which is what these were developed for.